Excellent. So just for a ground rule that if you have any question anytime, just raise your hand. We will discuss together. It's an informal session, so don't think too much. Just if you have any curiosity, anything to know, any doubt, please raise your hand. So today we are going to talk about system design, and let's start. First of all, you see a big number, right? Can anyone tell me that what is this? Like how many millions or billions or trillions? What is this? Anyone?
You can message in the message box for everyone.
Yeah, nice. 2.3 billion. When you do the system design and about scalability, you need to know these kind of things. When it is million, when it is billion, and you need to be very much familiar with this kind of numbers. I think everyone is familiar with this interface. This is Instagram. So in one report, Instagram said that they have like 2.35 billion monthly active users. 2.35 billion means like huge. Normally in our systems, we normally have million users, but Instagram has billions of users, monthly active users. But what happens when you open the app to scroll through your feed? You always find that it is instant. It doesn't have any lag there. It's seamless. Whatever you want to try, you can do it very easily. And it is not like all cached data. You just say that, okay, probably this is all cached things. No, you have your personalized feeds, you have stories, you have messages. So that means it is something that is not normal and it's supposed to be available 24/7. And how is this possible? From our point of view, when we work in a like smaller environment, we have one database, one system, and we serve probably 500 users or 1000 users. But when we grow up, we build things that is totally different. Suppose as a user, what you see, you just see a mobile app or web app where there are some screen there. But behind the scene, there are thousands of servers running. There are a lot of communication is going on, and that is actually system architecture. And we are going to discuss about that. Normally, these diagrams are like this or this or this. So it seems like overwhelming now, like, okay, a lot of things going on here and there. But when we simplify it, we'll go one piece by one piece, then we'll find that it is not that much difficult and how we can find the patterns and how we can actually design a system architecture. So, as you guys already know, like why should we learn system design? Definitely, we want to handle high traffic and large data volumes. Suppose you upload videos in YouTube, so you get a huge data going on. And if you have millions of users and you have megabytes of data, then it becomes like petabytes of data. And how you will manage or handle distributed system. That's why you need to learn this. Another perspective is when you design a system as a system architect, you need to know the trade-off between performance, cost, and complexity. It's not like for all the cases, same system design will work. There is no silver bullet for that. As a system architect, you need to figure it out that which one is useful for you. And your CEO will not know that whether he wants performance or cost or complexity. It's your job to advocate your decision. So that means if you are a technical lead or architect or engineering manager, this is the must-have skill. If we just know how to do coding, that will not give you that ability to play those roles like technical lead and architect or engineering manager roles. The most important part I find that you will be more effective decision maker when architecting solutions. That is that is the most important part as an like a system architect or principal engineer, because your decision will decide how much cost it will be and how your CEO look for funding. They need to get a number that okay, we if we need to serve that many users, how much money I need to raise. So this is your job to make a decision and advocate it so that everyone in other parts of the company can go and raise funds for that. Okay, so we have learned something. So let me tell you who I am a little bit. My name is Shafiq Ahmed Faruqi, and you can find my LinkedIn. I will share with you guys this slide. I actually work for many companies. So these are the main companies I work for. So I work for Codemate Limited, where I supervise in uh, Nokia. Then I worked as a technical lead in Intelligent Money. Then I moved to iPrice Group as a software development lead. Then I also worked for The Clinician. It's a New Zealand-based company as an engineer manager. And then I moved to Canada, and I'm working as a like individual contributor, engineer 3 and Proposify. So throughout my journey, these are the places I have worked with either physically or remotely. I worked for Canada, Finland, Bangladesh, Malaysia, and New Zealand. Okay, that's all about myself. If you guys have any question, you can ask that later or in the group chat. But first of all, we need to know, what does system design consist of? People have like different thought about system design. There are many things can be inside the system design term. Some people may think that probably even UI design is also a system design because they have a term called design systems. So we need to know that actually what does this system design means. It is not the UI part of the design, or it is not the marketing part of the design. It is actually two main component. One is low level design, another is high level design. So there are like two levels of system designing. So I'm not sure whether you guys already faced any interview on FANG companies like Amazon and other Facebook, Google. These companies have this distinction between low level design and high level design interview. So some of the interviewers ask you about low level design part. Some of them will ask you about high level design part. So we need to know actually which one is low level, which one is high level, or what we are going to talk about. So that's why we break it into two parts. Not all the people talk in the same language, but most of them knows what is low level design, what is high level design. So we are going to understand more about these two types of design. So what is low level design? Low level design is designing the implementation details of a system, like how we implement, how each classes communicate with other classes, each object communicate with other object. Is there any inheritance or not? Is there any abstract class or not? So these are the design you need to do in low level design. I'll come up with more examples as well, but on high level, when you do the implementation, that is part of the low level design. But high level design is the top level overview of a system architecture. So system design, when you talk about system design, it can be both. So we need to know when interviewer or your CEO ask you that, okay, we want to build a system, then you need to come up with the plan that, okay, we need to high level design that if it is a distributed system, how it will work, where will be the database, what kind of database you are going to choose, and how they will communicate to each other. And after that, you need to plan it out that, okay, so each and every class, how they will communicate to each other. So these are the two distinction between low level design and high level design. So let's go a little bit detail. Suppose someone asks you that, okay, write classes to design a pizza ordering service. How to calculate price according to toppings. So if there are like different toppings, you need to change the pizza order. How will you do that? So this is actually low level design where you write some classes. Okay, there can be like order class, there can be pizza class, there can be toppings class. So whatever the design is, you think in a class-based architecture, you can do that. Also, if you want to make an API request, how the design will be like /order/order ID. That is the URL. That is the part of this low-level design. So how you design your API, that is also low-level design. Even if you design the database, suppose you choose NoSQL or SQL, whatever you choose. Suppose you choose SQL, database RDBMS, then what you will do? You will make some tables and probably some order table, and it will have some fields. These all are part of low level design. So low level design consists of mainly object oriented design. That means you need to know about polymorphism, inheritance. So all of those you need to know. And also you need to know about design pattern. There are few patterns that can solve similar kind of problems. Like if you use singleton for database reader, so you can use that. That is a design pattern. So when you will use what, that is your low level design part. You can use singleton, you can use factory design pattern, you can use observer design pattern, or there are a lot of design patterns. In low level design preparation part, you also need to know about design principles. What is solid principle? What is single responsibility means? So what is DRY? Don't repeat yourself. When you use that, Yagni, you are not gonna need it. Like something you want to build, okay, as in software engineer, you want to build something, and then we know that the user will never use this feature. So we are not going to build it. When we need, then we will build. So that is Yagni. So this kind of design principles you need to know for low level design part. Also data modeling, what I discussed earlier, that if you want to design schema, that is a part of low level design data modeling part. Also, you need to learn how to handle errors, logging, exception handling. This kind of things are part of low level design. Since we will discuss about high level design problem, so this is one of the problem that you will get. Design a high performant pizza ordering system that can handle 10,000 requests per hour for a pizza chain. Suppose uh, you joined in Pizza Hut and they said, okay, make the pizza ordering system. So you need to draw a diagram for that. You need to think about that. Okay, 10,000 requests per hour it comes. Okay, so how can I make a system that actually that can handle this one, and how can I make a system that can transport the order according to their qualifiers. So it actually consists of this kind of things like scalability. So if we have more and more requests, how we can handle this? If we have like performance issues, how to solve these performance issues? Like what is the bottleneck? If there is a bottleneck, then how can we replicate those? We need to understand the interface and the integration. Suppose there is like payment gateway, how we can integrate those, which service will communicate with payment integration, and after communication how you are going to log it. This kind of things, data flow, and the final one is security. This is also part of high level design. So if we know all of those parts, at least these 5 parts, then actually you can actually draw your own system architecture. So I think that will help you a lot on like performance improvement and even interviews as well. Okay, since we learned about HLD and LLD, I have few questions. You guys can oh, like type it into the message and we'll have some fun time here. First question: which diagram is commonly used in LLD? Deployment diagram, sequence diagram, context diagram, or use case diagram? Okay, I got some answer here. Nice. I think I have got quite a number of answers. Thanks for participating on the first question, answering this one. So let me just answer this part. So deployment diagram, from the name, we can understand that how we deploy something. So that is not the part of LLD. Second one is sequence diagram. That means one class will communicate with other class, how they will communicate. That is the sequence diagram. And this is part of LLD. Second one is context diagram. That is not part of LLD. Use case diagram is something that is part of LLD and HLD both. So that's why when we have this Venn diagram, let me show, there are a few parts that are common for both the design levels. So that is one of them, like use case diagram. Use case diagram is like if you go through UML, then you know that use case diagram is one of the first thing we draw, and it is useful for LLD and HLD both. So B and D is the correct answer. Second one, what design principle is crucial in LLD? Is it solid principle? Is network latency optimization, cloud provider selection, high availability strategies? Looks like everyone knows the answer. Yeah, all of you guys are correct. It is solid principle. So let me go to the next one. Next one is this one. HLD is typically created after LLD in the design process. I can get some answers here. Yep, you guys are correct that HLD is typically created after LLD in design process. It's a false. So normally we need to design the HLD. Suppose we design like what kind of services we will build and how they will communicate. Suppose we are going to use Lambda functions, and we need to know that what are the languages it can serve and how they work. So that's how you need to define your high level architecture, then low level design will come into the place. Number four, HLD includes non functional requirements like performance and scalability. True or false? Cool. I think I got some answer here. It is true. And non functional requirements, when we think of LLD, we also think about non functional requirements, but that is very less compared to functional requirements. We more focused on the functional requirement, which suppose if there is a e-commerce service, then we need to think that okay, probably order search, order is one service, order search can be another service, product can be another service. So this is how we think in low level design. But in high level design, we just need to think okay, in order to scale this system, how to draw the diagram, what are the tools we can use. And last quiz here, which of the following is typically included in a high level design? Class diagram, flowcharts of system interactions, detailed code structure, database schema and queries. Excellent. Everyone is correct here. Actually, everyone understood that class diagram is for LLD, flowcharts of system interaction. That is the mainly HLD's job to cover. Detailed code structure and database schema is part of LLD. Okay, so we have done our quiz time, fun time. Now we just need to learn two major concepts. Normally, there are like a lot of concepts we have in the system design part. When you think about any system design, you can think of many things, but these two that we are going to discuss is actually maybe 95% time you need to deal with these two concepts. So let me give you a scenario. Suppose there is an e-commerce website that needs to display a list of products with their details, and there will be a home page, category pages. The product data is stored in a database. That's a generic e-commerce website. Now, what is the problem here? Every user visiting the website triggers queries to the database to fetch product details. Yeah, obvious. Now, during high traffic, like there's like Christmas time, flash sales, so the database become a bottleneck. And fetching data from database for each request introduces latency, degrading the user experience. What can be the solution? Can you can anyone write down on the chat box? Like what do you think? What can be a solution? Any other? Okay. The obvious solution is caching and cache the product list details in memory and store frequent access data like product categories, individual product details, search results. And for caching, there are a lot of tools out there. So, like, but in memory caching wise, Redis and Memcache is very popular. But in AWS services, actually, there are a lot of cache there. Elastic cache is there. And now the second concept. First concept we know about the caching part that we need, always remember we need to be like master about caching part. But this is the second concept. A video streaming platform like Netflix or YouTube serves millions of users globally. The platform needs to handle large volumes of simultaneous video requests. So there are a lot of requests, either it's video or some other things, but there are a lot of requests. So, but we don't want downtime or any delay. So what is the problem? All user requests may be directed to a single server, causing it to crash under high load. So if there are like 2.35 billion requests, then definitely it will cache. Sorry, it will crash. And some servers may remain idle while others, suppose we have like, okay, multiple servers there. So some of them remain idle, so while others are overwhelmed, leading to inefficient resource usage. Do you know how can we solve this problem? Like a lot of requests coming in, and how we can solve all of them. Anything you have in your mind, you can write it down. Horizontally scaling load balancing. Yep, correct. Load balancing is something that is actually very much useful. How it is implemented, that is important. But the normal solution is like you need to place a load balancer in front of pool of backend servers. That means you have to have multiple backend servers, and in front of them, you need to have a load balancer. AWS has like security groups, and AWS has a lot of options to load balancer, application load balancer, elastic load balancer. So you can use those kind of load balancers, but you need to have this load balancer in front of all the backend servers. Second
Sorry,
thing,
sorry to cut you here. I
sure.
see a lot of people, they mentioned about CDN, and from my experience, what I've seen is that CDN plays a great role in offloading the resource bottleneck a lot. So, can you please answer, why CDN, when we have to choose CDN versus load balancer? Like the example that you provided, like YouTube or I mean, video. If you're hosting videos and you need to serve to millions of users, then when should we use load balancer versus CDN?
Sure, that's a nice question. Actually, I think that is what we all need to know about. And CDN is content delivery network. So that means CDN, you need to keep the content in some places, normally geographically in different places. And either you have like JavaScript file, image file, and other files in there, and you serve from that. If you need performance improvement, you can use CDN. And CDN is normally for static contents. So you can have this one. But if you need something like non-static content, like dynamic contents, then you need to have load balancer where you can send the post request and it will find it out like in which database it will write, or in which storage it will write, in which service uh, it will process. So load balancer is normally whenever you have the dynamic data, and most of the times you have, whenever you have static data, you can keep it in CDNs, and that will help you like improve the performance. The load will be less. That's the thing. In short, does it make sense?
Thank you.
Cool. So we were here like whenever the request comes up, we can implement load balancing in a different ways. One is round robin. Second one is round robin means actually it will actually go through all of the servers. Like first one, first request come to the server one. Second one, server two, server three, server four. And then again it will go to the server one. So this is how round robin works. And least connection is something that a load balancer will check which server has least connection. Then it will transfer those requests to those servers. A third one is geolocation. Geolocation wise, there can be a load balancer that, okay, you have a request from Australia, so you'll get server from Australia. If you have If you requested from India, you have got the you have the response from India or Singapore. So wherever the server is. So that's how load balancer also works. These three algorithms. So geolocation wise, the load balancer is similar to the CDNs. CDN also do the similar things, but CDN keeps the static contents. And for example wise, we have used HA proxy. This is dedicated for load balancer part. Nginx, which can be an web server, plus it can be a load balancer. AWS has ELB, which is very much popular. So we can use any of them. Cool. Any more question about these two concepts? Let me check the message. Uh, if you guys actually have any question, you can actually let me know. Cool. If there is no question, let me proceed to our next part, design visibility. This is very important part. When you are coding, you actually write down in your editor, you have files. But when you are doing system design, you cannot actually just write down in your file, and in real world scenario, you need to know how to make it visible for everyone. Coding is visible for developers only. Other people normally don't understand and don't want to know what you write there. Your visibility is only within the development team. But when you are doing the system design, your system design needs to be understood by all the developers, QAs, product people, and on the upper world, the C-level executives, because they need to raise funds according to that. They need to understand what is going on and how they can sell it. So design visibility wise, suppose if someone asks you that, okay, we need a feature like DocuSign, build it. What you will do? Maybe you don't know what is DocuSign is. Maybe even I don't know like what is DocuSign is, like what are the features they have. What is your job then? Like how can you draw a diagram if you don't know things? So your first job is to clarify. First job is to clarify that okay, what is DocuSign? What are the features we are going to build? If we need to build a system, whether we are going to build all of them or some of them, which one is most important? Whom do we serve? This kind of question you need to ask, and you need to figure it out, either asking or researching. Second part is visualizing. That means you need to draw a diagram. When you draw a diagram, then you can talk with the people that okay, this is the diagram I drew. I think this is the way we need to make the system. Then they will come up with the feedback. The last one, get feedback. They will come up with the feedback. Okay, no, I don't think you have considered this case. I don't think you have that much budget to build this kind of architecture. What you can do? So that's why you need to do all of those. For clarification part, your work is sitting together with all the stakeholders. Clarify the requirement. You need to visualize this one, that you need to use Miro or FigJam. I'm not sure whether you have used this or not, but these are the things where you can brainstorm together. Like you think that, okay, this is the service we want. This card, every service is a card, and then you can group it together. Okay. So everyone gives some feedback, and then you would say that, okay, these are the things we are going to build. So in order to clarification, you can use FigJam and Miro, and that is a must thing. You need to do this step. Even for interview part as well, if anyone comes to me or any other interviewer, and if they don't ask any question, that okay, I got this idea, I just start building, that means we understand that actually that's a red flag. So you must ask questions, clarify, even though you understand entirely. You need to say that okay, I understand these items, whether I am right or wrong. So when you get the feedback, okay, you're right, then you start drawing the diagram.
So Farke, I have a question.
Sure.
Most of the companies that I've worked for, I've seen that I mean, the company uses Microsoft Suite a lot, right? So I mean, some of the companies they don't really have Miro or FigJam as tools, like purchase tools, and it's a complicated process to to convince them to buy these tools. So, do you know um, any Microsoft tools that could have done the work, could do the work for us? Any substitute? Just a quick question.
Microsoft wise, I have very much less idea. Visio is a tool that is actually used for diagram drawing. I'm not sure whether they have this brainstorming part as well. If they can collaborate, then I think that would be a good tool to use. Goo- Google also has some tool like here you can find like Jamboard or something. Yeah, Google has some tools. I forgot the name.
Okay, but FigJam and Miro are like the go-to place, go-to tools for doing clarification. Is that
Exactly.
okay?
Yeah, collaborative work you can do it using this kind of tools. SharePoint for conference replacement. Yes, SharePoint is the last one that I was going to talk about. Okay, Mural. There are quite a few tools for that. So when you have this clarification, then you need to start drawing. And as a system architect, when you draw a diagram, you need to be handy with that. If you are like if you're not very much familiar with the tools, then your drawing will take more time, and that is not expected because that's your main job, is drawing the diagrams. So you need to know the draw.io or lucid draw or uh, Microsoft Visio is a very good tool for drawing. And when you have this kind of tools handy, you can easily understand and change things whenever you get the feedback. Now suppose you have the diagram, you know this one you have planned, use it seems that everything works fine, but it is your one brain is working there. If you want multiple people to think about this one, like what happens in the coding part, we open a PR, people look at the PR, see that what are the changes, and then give feedback. Okay, fix this one, fix that one, make it better in this way. Probably something is excessive. You can delete those part. Exactly same thing can be done in system architecture. So if you draw the diagram, you need to come up with a plan or a strategy how you can get feedback. So either you can use Google Docs or Confluence or any other tools that you can use. But normally what we do is actually we use Confluence and we call this document is RFC, request for comments. So different levels of people watch this one. Okay, some of them has different perspective, totally different perspective. Then they say that okay, why don't you think about this? You need to advocate your draw diagram that at that time that okay, this is the reason I use multiple layers of tools. So that's why you are drawing this diagram. So RFC is for the comments. You need to get the feedback and make it better. When your RFC has a lot of feedbacks and you made it better, all the things covered, then someone need to approve that one. If one of the person is authority or multiple people is the authorized person who can actually approve this diagram, then you start doing the LLD and other parts, coding part. But this is something that you need to do. So always think in this way, that first you need to clarify, second you need to visualize, and third you need to get feedback. If you have all those three, then you are ready to go.
So, Furky, I just wanted to ask one more question.
Sure.
So, if you go back to the last slide, so you see that here we have the so for the primary brainstorming, we have Miro and FigJam, which is great.
Mhm.
For visualizing, we have LucidChart and Draw.io. Now, the question here is that I have seen many people using LucidChart and Draw.io to to draw the low-level diagrams. So now you're saying that we do the low-level diagrams after we get the feedback and the RFC has been approved, right?
All right.
So what happens in the visualized part? Because I thought you mentioned draw.io here. The visualized part is actually for doing the low level, but it looks like it's not.
No, this is for high. Okay, this is a drawing tool. So when we do HLD, we will use this tool. Even when we do LLD, then also we need this tool,
Yeah,
lucidchart or
but
draw.io.
in the visualized part, did you mean that we're in the visualized part we'll be doing HLD, a high level design?
Yes,
Uh,
I, I
okay,
I meant the high level design need to have the diagram first.
got it. And then after the RFC is confirmed and approved, and then we do the low level one.
Exactly.
Excellent, excellent. Thank you for the clarification.
Cool. Here, actually, we need to remember one thing, that uh, how I'm talking, it sounds like it's a waterfall design pattern. Like we are doing first HLD, then LLD, then coding. Normally, what happens is it goes parallelly. It's not only one thing. Like some of the things already going on, developers are working on something, and system architect need to think ahead of product and also ahead of everything, ahead of delivery. So then they need to build the diagram at that time. And developers job, normally programmers job, is that time is just to see and give feedback. And most of the task is here for system architects. This is the most fun part, that is we are going to do some design in action. I would like to actually ask you guys, if possible, create a draw.io account. This is free, and if you can draw with me along with this one, that would be great. But I already have this one. If you cannot, it's also okay. I'm giving you like 30 seconds to create one account in draw.io, apps to diagram.net. Thank you very much. Okay, so I hope you guys already created or on the way to creating accounts. So it's an optional thing. If you do it, good. If you cannot, it's also okay. So this is the problem. So let's discuss about the problem. The problem statement is design a weather forecast web application that gets data from a third-party API like OpenWeather. So there are multiple APIs, but your job is to build an application that gets data from third-party API and display. So that is the basic problem that we need to solve. How we are going to solve this problem? So let's go step by step. So our app's name is weather forecast. First of all, we need to clarify. In order to clarify, we need to ask questions. Normally, when we ask question, we get this kind of requirements. One is functional, kinds of requirement. Second one is non-functional requirements. First one, we need to give them option to input location and time, because suppose I want to know what will be the weather tomorrow in Florida. So I need to set this one. So that's one function. Another one, get weather forecast by hourly or daily and determine the location by IP. So suppose I want to show a home page where I want to just display that if you allow your geolocation, it will show the current weather of that location. That is the functional requirement. Now, since we are discussing about high level diagram, we must ask non-functional requirements. We need to target, okay, how many users we are targeting? Is it like 3 millions, 300 millions, or 100,000? Suppose we'll start with 100,000 users daily. They will come daily, and we want the system because have we don't have much budget. We want it cost effective. We want it fault tolerant. And do we want it like highly secured or not? Server wise, probably we need the highly secured server, but since users will not log in, so we don't keep their information. So security is not the major concern here. Major concern is whether we can serve 100,000 users or not, whether it's a cost effective or not, whether it's a fault tolerant or not. Suppose API is down for some time. Can we serve anything or not? Okay. If possible, you guys also start drawing these parts in draw.io or whatever tool you like. But let me just explain here. So when you start designing any diagram, make the most basic one. We have only one kind of user who will send the request here according to our problem specification. So this user will ask the weather forecast application that, okay, give me weather forecast of that place. It will give you that place. That's the basic one. Whenever you are trying to make a diagram, make this fast diagram. There will be user, there will be API. What is the weather forecast application? Now we need to remember that we have some non-functional requirement. Plus, this third-party API gives you some factors. You need to remember that one. Cost per request. If they say that, okay, per $1,000 request, you need to pay $2. And daily active user, we know that 100K, and uptime is 99.99. So cost per request, if we think, it will be like $0.002 per request, and per 1,000 requests is like this. So considering this part, we need to come up with some assumption. These assumptions are like this, that how many times one user will request? Okay, maybe 5 requests per day, including location searches, weather updates, altogether. So this kind of assumption will help us to build the system. Second one, data size per request. Suppose it is 50 kilobyte. It's just, there is no image upload or anything, just request. API calls. Each request hits an external weather API. That's what we assume, that every request will go to the external API, and external API is costly. Every request will cost me $0.002. Now, according to the assumption, we need to do some calculation. The request per day is 5 into 100K equals to 500K. So that many requests need to be served. How many data transfer per day? If we think that it is 50 kilobytes, then 25 gigabyte per day is not low, it's quite high. So we need to buy those storage where we can, sorry, we need to think about the bandwidth where we can see that 25 gigabyte per day is there. The third part is the most important part for the CEOs. That is, okay, how much money it will cost for how much we need to pay to the open weather company. If it is like 500K request, then it is $1,000 per day. So per month is like 30,000. This calculation is called back of the envelope calculation. So if you face interviews in uh, like FANG companies or other companies, then you definitely need to know how to calculate these kind of things, how to do the assumption, how to calculate, and then you come up with the drawing. But if before doing this kind of calculation, if you start drawing, that means you are not considering these factors. Cool. So our one of the objective was reducing cost. How can we reduce cost? How can we not call API every time? We can see that we can have our own storage. We can call it cache or database, whatever we call it, but we have our own storage. That means if like 100 people from Canada or Nova Scotia, they ask for the like daily weather forecast, you don't need to go each and every time to the API. You can just say store once, get the data once, store once, and serve for 99 times. So you are saving a lot of money if they are like similar kind of requests. Now, if you want a separation of concern, that front end part has a different responsibility. That means you need to display it nicely. You need to give the input format. You need to think about the GEO part. But backend part is only get the data either from the API or from the cache. So this is two different things. So when there are like two different things, we can have these two independent services. One is like front end, one is like back end. Now, how they will communicate. I'm not sure whether you're familiar with this or not, but mostly most of us familiar with API. So front end will get the request from the user. It will have a contract with backend that how it will send the request. What are the information it wants? It sends to the backend. Backend will do the response, do the all kind of processing, like find out like, okay, what is the request? What kind of API call I should do? Whether I have this data already in the database or not. All kind of processing backend will do and send back to frontend. So this will be the simplest way to make a separation of concern independent services that communicates with each other and serve the purpose. Now comes the scalability issue. As we know, like it's like 100K or 300K, whatever user is there, all of them going to front end say that, okay, I want this information. And front end, all of them saying to backend, okay, give me this information. And it will go to the database and get this information. That means there is a high chance that front end will die, backend also will die. Normally, they can serve maximum like few hundreds requests, like front end can in 1 second they can send that many requests. So we need multiple front ends. to serve all 100K requests. We need multiple backends as well. We need multiple database as well. So in this diagram, if you look at it, you can see that at the very first part from users, there is a load balancer. That load balancer actually sends this request to multiple front ends. So we need to find out how big server is. Like in AWS, there are like EC2 servers. If we take like T2 like there are different sizes as well. So if you take the servers and figure out like how many requests one server can serve, that many server you need to assign. Okay, I need 100 servers, and there will be a load balancer that will actually communicate with all the servers, either round robin or some other algorithm they will use. But this load balancer will balance the load of the request. Then front end will say that, okay, I also got a lot of requests, and in order to handle those, I need a lot of backend servers. So you need to assign a lot of backend servers, and this API will go through this load balancer. Then when it all of the requests are passing through front end and back end, then the database will be the bottleneck. So you need to have multiple database as well. That will either you can make it like read and write replication, or you can have all read. So all of them will synchronize, keep the same data, but it will serve different requests. Now we know that this is the architecture that can actually solve this problem. If we draw this diagram and if we can implement this one, we can solve all of those. But there are a lot of tools that can help. So what we can do here, like what are the AWS services we can use so that we can we can use it cost effectively, and some of the things we don't need to manage, AWS will manage. Their service level agreement says that, okay, I will make sure it will be like uptime for 99%. So we can leverage these tools for this diagram. How can we do that? Let's see. So last diagram, you can see that there is an API and there is a load balancer. AWS has API gateway that actually can do both. They can maintain API security, scalability, and also they can do what do you call some caching as well. So all of those can be done by API gateway. So why don't we use this one? So if you use AWS API gateway, we can actually use it for load balancing part. So we don't need to have multiple things. And we talked about EC2 servers. EC2 servers are like cloud servers that runs, always running. So that means it always have some cost. You need to pay for that. But do we need that many servers always ready for requests? Maybe we don't need that one. We can optimize our cost using AWS Lambda. This is called serverless architecture. That means you don't need to maintain any server. You just need to define the function in a Lambda environment. Suppose you said, okay, I will write a function where it will read from the database. If it is not in the database, it go to the cache, go to the API, get that data, and warm up the cache. That is the responsibility for one Lambda function. And AWS service is so good that if you configure this one API gateway properly with one Lambda function, then Lambda function will actually fan out according to the uh, number of requests. The more requests it will come, it will actually automatically scale up. So instead of EC2, you can optimize more cost using Lambda functions. Now, from the front end, is there anything you can do or not? If you know this tool, this icon, this is the S3. AWS S3 is something that actually I think everyone likes this. I also like this service. S3 means simple storage service. What it does, it keeps the information, like if it keeps the static files like CSS, JavaScript, HTML files, they can just keep it there. And they have auto scaling there. It is always available. And it is actually can serve from different areas or different AWS zones as well. And from our perspective, our front end doesn't need to do much processing. They just need some JavaScript to go to the API call. They need some HTML to make the structure. And then they need some CSS to make it beautiful. Maybe there will be some images or animations, and all are kind of static files. So if we use S3, we can serve all the users, 100K users using S3, and it is very, very cheap. You don't need to think about anything else. Then all the requests will go to API gateway, and API gateway will do all kinds of routing. It also write down the log as well in the CloudWatch, and it actually solves all the problem of scaling. So if you use S3 API gateway Lambda function, and if you have any database, done. Your system is actually capable of serving more than 100K users. I think I just need to recap this part quickly so that we can understand. Whenever we get this requirement, we need to come up with more questions and find out what are the functional requirements and non-functional requirements. If we have those in our notepad, we need to start making the diagrams. We'll make a most simplistic approach, simplistic diagram here, and then we need to do some back of the envelope calculation. That means this calculation doesn't need to be accurate. Normally, when we have an envelope, we do some rough calculation. This is the part where you get the factors, plus you need to do the assumption. When you do the assumption, that is the most important part. When we go for an interview and we don't know how to do the assumption part, then we mess up with the numbers and we don't know how to draw a good diagram. So we need to practice this assumption part. Then we need to do the calculation, exactly how many requests we are serving, request per day, data transfer per day, and cost per day. If we can calculate all those three, then we know what we are going to handle. First one, reducing cost. Second one, separation of concern. Third one, how they will communicate. Then we need to figure out how to scale. And when we are going to scale, what kind of tools we can use. We can use API gateway. We can use Lambda function. We can use S3. That will actually cover the most simplistic approach. Since we are doing the first day, so we are not going to discuss about the event-driven architecture and other things. We just have this one. If you guys have time, you can just draw this diagram. It is simple. But when you try to draw the diagram, then you will see that there's something is missing, or some kind of icons you don't know. So you need to actually practice by yourself to become like master of drawing these kind of things. Cool. I think I have covered first day's things, but let me just give you some glimpse of the next session. In the next session, we will have
Okay,
sorry, you
sorry
can.
to cut you. I just I just wanted to allow everyone to unmute themselves and ask any questions if you're okay with that before we recap the next sessions. Is that cool?
For me, it's good.
Excellent. So I'll just allow everyone to unmute, and if you have any questions, just go ahead and shoot.
Sure.
Thank you. Yeah, please proceed. So everyone, if you have any question before we move to the next session, which is basically sharing what's going to be covered in the next in the next 2 weeks, um, please unmute yourself and ask questions if it's easy for you.
Could you solve this without using AWS? It's a good question. Definitely, we can solve this without using AWS, and we should know how to do this without using AWS or GCP or uh, Azure. If we know how to draw this diagram, then we know that what we can use. We can use actually load balancer as it's like HA proxy. We can have our own server where we can put HA proxy as a load balancer. We can have Nginx as a load balancer as well. And because we don't have like Lambda functions, right? So we cannot do that. But if we Dockerize our things and if we have multiple servers, then actually we can uh, implement these multiple front ends and multiple backends in our own servers. Whatever Linux distro we want to use, we can use that. If we have a physical server in our premise, we definitely can do that.
Yeah, I just wanted to add, it's a great question. So I was just thinking that sometimes cloud providers, they can be expensive as well. So I have seen some of the companies, they're now into cloud, and they're like promoting a new era of hybrid cloud, where you have an on-prem and you also have cloud. So you use, based on your scenarios, you go on-prem or cloud. So one solution could be, it's a great question. One solution could be is Kubernetes, right? So if you have your own Kubernetes running, then Kubernetes can help you with scaling, auto scaling as well. That's a great solution in my opinion. I hope that answers the question.
Yep. Uh, Asal, I think that's a great answer as well. Another question, I think you can remember that we have built uh, probably 7 8 years ago uh, one PABX system and CRM together in our on-premise system, where we had the communication between PABX telephony system with our what do you call CRM systems. So I can remember those things.
Yep, I can remember. Thanks. So if there is another question regarding cybersecurity.
Sure. Definitely, we need to think about the security part, and because this is like very basic one, so then we didn't discuss about the security part. But there are few tools for that. Mostly, I work on AWS, so I come up with the things like WAF, where we have a firewall where we can actually set up this firewall, and we take the advantage of those tools for having a secured system in front. But there are some I forgot the name OWASP, that there are like 10 security measures we can take and make a secure system, but that all of them not part of high level system design, but some of them are definitely on the high level system design. Thanks, Lauren, for the nice questions. And yeah, definitely, uh, I think if I can have some time, then I can make some uh, knowledge sharing session about security part as well. Yes, this one.
That would be absolutely fantastic. So yeah, thank you.
Any more question? Okay, I think we don't have any more question right now, but you can ask me anytime, or you can ask Arsenal as well, or any kind of curiosity or any kind of question, any kind of doubt. We are happy to help. Actually, I enjoy sharing knowledge, so even I can learn new things as well. So it's all good. For next session, probably not the next week, probably next week, but we will try to cover some of the advanced topics where we'll discuss about event-based architecture when we need to design in a way that we can make sure that there are less dependencies, less coupling on the services, and when we design a diagram and there will be like a lot of requests of non-functional requirements that okay, I want this and that and this and that, what we can actually provide and what we cannot provide, that we can actually discuss on cat theorem. We'll do another design exercise a bit different than this one, maybe a bit more features will be there, and we also discuss about different kinds of APIs, so so that when to use what kind of protocols, you will understand that part. System design is very vast, but we'll try to cover only few parts which is mostly important on most cases, and then we will learn, we'll go deep on that. At least you will know the terms, and if you're familiar with the terms, then you know that what to learn. So these are the four main topics we will discuss. I think that's it. Anything else?
Thank you, Farki. It was indeed a great session. I shared a link in the chat where I'll be uploading this video once it's ready. And someone shared, someone asked a question, any standard like TOGAF that you recommend?
I'm really sorry that I'm not very much familiar with TOCAF standards, so my recommendation will not be actually very much useful. So that's why I'm not going to recommend anything. Yeah,
Thanks, Farki. But I heard a lot of good things about TOGAF, and
yeah,
I,
definitely,
I, I do I do plan to learn more about it. But I heard there's a lot of good things, and there's a lot of a lot of good courses out there as well.
exactly. And this, even in job market, actually, TOGAF is quite popular. So I would recommend to learn, but since I have not much knowledge about that, so that's why I'm not saying anything here.
Thanks, Farki. So the next session would be on the 23rd.
Yep,
Is that if we
23rd.
on the 23rd? So that'll be the second session, and on the 30th will be the final session. So thanks so much, everyone, for joining. And we look forward to seeing you in the next sessions as well.
Thanks, everyone. See you.
Thanks, everyone.
So I'm just stopping the recording.